All right, this is probably the last video that I'll deal with on this topic of inverse functions integration, and this is example 5, and there isn't a lot of room. This is on the back side of the notes, and I didn't realize I didn't give you that much space, and it's kind of a tricky one. Again, I take a look at reversing the power rule, and when I do this, it's to the half power, and if I take the derivative of this, I get a negative 2x, and I almost have it. I have this x, but I have this plus 2. So it looks like you might be able to do this without using an inverse trig function. And what I'm going to do here is I'm actually going to break it up into two of them, which is this. So this is the first plus, and then here's the 2, and I'm going to put this over here, and I got 1 over the square root of 4 minus x squared dx. Now this one kind of looks like the previous ones I've done before, so this kind of looks like the inverse trig function, and let me just break it down a little bit more. I'll do this one first. Here I have the square root, and I have 2 squared minus x squared dx, and the derivative of x is 1. And so this, and here's my a, so a is equal to 2, and my g of x is equal to x. So what I have here is the arc sign, and so this is going to be plus, I'm going to do this integral first, 2 times the arc sign of g of x, which is x, over a, which is 2. Now I got my plus c. So I'm over halfway done. I just have to take a look at what this is, and if you notice I don't have a constant here, and the derivative of this is a negative 2x. So I'm going to do this one separately like I've done on previous problems before we got to this particular section. I'm going to let u equals 4 minus x squared du dx is equal to a negative 2x, and du over a negative 2x is equal to dx. So I can do substitution here. Here's a negative 1/2. That's that negative 2 from here. And over here I'm going to have x. Right here I've got u to the 1/2 times du over x. So these x's will be simplified, and I can write this even further as a negative 1/2 u to the negative 1/2 du. Okay, so this is reversing the power rule, and by that I mean I'm going to add 1 to a negative 1/2 and get 1/2, and then multiply by its reciprocal, which is 2, but remembering that I have this negative 1/2 out here. So when I multiply, I get negative u to the 1/2 power. Well, what is that? Well, I'm going to write that all over here, because this is going to be finish my integration. Negative square root. What's inside my square root? My u, which is 4 minus x squared. So what ended up happening is I had to figure out the integral of both of these differently. One used inverse trig, and the other one used reversing the power rule. And so that is quite common, in which you need different methods. All right. Now I'm going to take a look at something called completing the square. And if you recall, if I have something like this, x plus 3, the quantity squared, I get x squared plus 6x plus 9. And if you take a look at this, this is really 2 times 3x. And this 3 is really 3 squared. So when I have something like this, x squared plus 10x, to complete that square I would take half of this, which would be 5. That's what 10 divided by 2 is. And then I would square that 5, and that would be this n term. So this process is called completing the square. When I take this b coefficient, divide it by 2, and square it. So let me give you another one. Let's say I have x squared minus 16x. Well, half of this is a negative 8. And if I square negative 8 squared is going to be 64. So this is a trinomial square, which means it can be written in this form, x minus 8, the quantity squared. So that's the process of completing the square. I'm going to do another one here, and it looks like this. It's already a trinomial. It's going to be x squared plus 2x plus 7. And I'm going to complete the square. And one way to complete the square is take half of this 2, which is 1, and square it, and I have 1. So I can rewrite this trinomial as x plus 2x plus 1. Where did I get the 1? I took half of 2 and squared it, plus 6. Where did I get plus 6? 1 plus 6 is 7. And I'm simply going to group these 3 right here, because these 3 are a perfect trinomial square, which means it can be factored into this form. X plus 1, that quantity, squared plus 6. Or this is the same as 6 plus the quantity x plus 1 squared. So if I reverse this process, x plus 1, the quantity squared, is x squared plus 2x plus 1, and 1 plus 6 is 7. All right, let's try another one. Let's have this. X squared minus 6x plus 13. And what I do is I take this x squared minus 6x, and I give my little space here, and I'm going to write plus. And I know that these two numbers have to add up to 13. So, because that's what I have right here, 13. So when I complete the square, I take half of a negative 6, which is a negative 3, and square it, and I get 9. That means this has to be 4, because 9 plus 4 is 13. And then I group these first 3 terms, and that can be factored as x minus 3, quantity squared, plus 4, and I'm going to write it in this form. 4 is 2 squared plus x minus 3, the quantity squared. All right, now I'm going to show you where this works with inverse trig. And here is the example I'm going to do. I think it's example 6 in the notes. I'm going to write the 1 up here. And I'm going to write x squared minus 4x plus 7 dx. Now, if you notice, I'm going to put these in parentheses, raise it to the first power, because I'm looking to see if I can do the natural log. The derivative of this is 2x minus 4, which I don't have up here. So I'm going to write it in an inverse trig form. And notice I don't have any square roots, so the only choice I have is arctangent. And arctangent looks like this. It's 1 over a squared plus g of x squared dx, where this is equal to, just give me a moment here, 1 over a times the arctangent of g of x over a plus c. Alrighty, so I want to get this form, so I need the constant first for the function. Well, to do this, I'm going to complete the square. So I have x squared minus 4x. Now, what do I need here? Well, half of a negative 4 is a negative 2, squared is plus 4. That means I have to have a plus 3 here, because 4 plus 3 is 7. So then that can be written Remember, my whole goal is to get like this. This could be written as x minus 2, the quantity squared, that's what these three terms are together, plus 3 dx. Now I'm going to get it like this form up here, which means I have to have the constant first, and I have to think about what constant squared is 3. Well, that's the square root of 3, plus x minus 2, the quantity squared, dx. Now let's take a look. Is the derivative of this? And it is. The derivative of x minus 2 is 1. So that means a is equal to the square root of 3, and g of x is a binomial. It's x minus 2. And so when I solve this, it's going to be 1 over the square root of 3. Again, I am using this form up here, times the arc tangent of x minus 2, that's my g of x, over the square root of 3 plus c. And that's my antiderivative. All right, on the next problem, what I'm going to do is I'm going to do a definite integral. In the definite integral, I ask you to figure out the area from 1.5 to 2.25, and I think I give you a graph of 1 over the square root of 3x minus x squared dx. Now I'm thinking about reversing the power rule here, but the derivative of this is 3 minus 2x, which I don't have. So it's going to be one of the inverse functions, and it's not going to be arctangent because of the square root symbol. So what I'm going to do is I'm going to do a process of completing the square. And over here I'm going to complete the square on the side. I'm going to complete the square of 3x minus x squared because I think it'll be less messy. And so this can be written as a negative x squared plus 3x. So I just reverse these two terms. And I'm going to factor out a negative 1. And I'm going to get x squared minus 3x. Now I'm going to take half of that, which is a negative 1.5, and square it and get 2.25. Now I just put a new number in here, so what I have to do is balance it out. And when I balance it out, I'm going to either add or subtract 2.25. Well, if I distribute this, this is really a negative x squared minus 3x, plus 3x minus 2.25. So what do I have to do? I have to add a 2.25. And if I do, these will cancel out and I'll look like this over here. So I've got a negative parentheses x squared minus 3x plus 2.25. Remember I added over here, so it's going to be plus 2.25. And it's going to look like this. A negative parentheses x minus 1.5, that's that factored, squared, plus 2.25. Well, this is the same as 2.25 minus the quantity x minus 1.5 squared. And 2.25 can be written as 1.5 squared minus parentheses x minus 1.5 squared. So now I'm going to come back and put that inside my radical. And over here I'm going to have 1 over square root of 1.5 squared minus parentheses x minus 1.5 squared dx. The derivative inside here is 1, so that means my g of x is equal to x minus 1.5. It means my a is equal to 1.5, And this is the term of a squared minus g of x squared, which is arc sine. So I'm going to have arc sine of g of x, which is x minus 1.5, divided by 1.5, evaluated from 1.5 to 2.25. So that's going to give me the arc sine of 2.25 minus 1.5 over 1.5 minus the arc sine of 1.5 minus 1.5 divided by 1.5. Well, this is the arc sine of 0. So the question is, what angle measurement is the sine 0? The angle measurement is 0 radians, so that's 0. And over here I have the arc sine of 0.75 over 1.5, which is the arc sine of a half. And what angle measurement gives me, the sine of what gives me a half? That's going to be pi over 6. So I have pi over 6 minus 0, and my answer is pi over 6. And I know there's a decimal equivalent out there, but I'm not going to figure it out.